Hello everybody, how's it going? Uncle Hawks, you heard correctly. There is coding about to go down very shortly. Welcome to the, I want to say 17th? Let me check my folder. The 17th Stray Basilisk coding stream. Today we are going to make, as voted for on our Twitter poll, a Plants vs Zombies clone of some kind. I don't know if there's anyone watching who has not played Plants vs Zombies. Let's Google this thing to see what it looks like. Take my cookies, Google. Wow, why can't I get just a normal screenshot? Okay, here's what the game looks like. And that's super tiny. Here we go, okay. So Plants vs Zombies is essentially a tower defense game, but it runs on this grid and in these kind of lanes. And the way it works is that you have this menu of stuff which you can buy and which you can plant in your garden. You can then place them down onto these various tiles, and then a horde of zombies will be slowly like encroaching and coming in from the right hand side, sort of down these lanes. And the idea is to protect your house. So if a zombie gets to the end of one of these lanes, then you effectively like lose a life. What actually happens in Plants vs Zombies, I don't know if he'll copy this precisely, is a lawnmower fires off and like mows them down, which kind of gives you an extra chance. But if a zombie gets into your house, then you lose. So it's a wave-based thing. Like a certain number of zombies will come down these lanes over a couple of minutes, and you need to place down your little turrets and other things in order to try and catch those. So we're going to try and produce some kind of version of this. We're probably going to use some of the artwork from Steamhounds, which is our main game project, because we've got those sprites all nice and to hand. And I think what I'll actually do is use the code base from one of our previous projects, because it does some of the basic like boilerplate code which we want to do already. So if you remember all the way back to coding stream number 3, we produced this little 2-button brawler game. And the way this worked was that you hold left or right and you can kind of charge up attacks, and there's this like stream of enemies coming in from either side. So there's some kind of similarities here. What I really want to steal is just the code for the sprite animations, because you know, that's not really the interesting part. The interesting part is the gameplay. If you're interested in how to load and display a sprite, then you can always go back to the stream to see how that's done. I don't want to spend half an hour just re-implementing that, so I'll probably cannibalize at least this little bit of code which does the sprite sheet animations. And I'll probably use some of the sim sprites for this. Okay, I'm actually getting caught up playing this now, which I should stop, but okay, let's stop. Yeah, right, because I kind of just want to focus on the logic and like what makes this kind of different. What I had done was just copy and pasted this whole folder, but I think I may not do that, and I'll just copy the animation and the sprite things, and everything else I'll just ditch. That's really the only thing I want to take. So the tool I'm using to do this, by the way, is called processing. So if you're not familiar with processing, it is good question. So I'm using something called processing, which is ultimately it's a Java-based framework. I use this because it's the easiest way I know. Okay, awesome. Yeah, it's the easiest way I know to get like graphics on screen in some form, like as quickly and easily as possible. You know, if you were to do a real big project with this, it would become a massive pain in the ass. But for smaller little toy things like this, it's great. Yeah, I mean, it has the tools you need, right? The reason I like this as well, you know, we could just use Unity and use the built-in animators and the built-in sprite system and all of that, but I kind of like to start from first principles and kind of explain how those things actually work. And processing gives us the basic tools we need, right? It can load an image, it can take input from the keyboard, it has like an update draw loop thing going on, so I mean, yeah, why not? That should work, right? There's no reason we couldn't use that to make our game happen. So I'm going to get rid of pretty much all of this and leave like some very basic skeleton stuff here. Don't know if we even need the keyboard. This can all go. Cool. So if you've never used processing before, then you won't know that we have this setup function. This is where you kind of do your initialization. And the very first thing you need to do, in fact, the first line you need to put here is kind of setting the size of the window. This just here is just the graphics mode. And I kind of want to make this 3D, I think. So, I mean, it will be 2D sprites, but in a 3D kind of environment. So I'm going to use the 3D mode. And even if you're doing 2D, you can still use this. It just makes good use of your graphics card and all of that stuff. The other thing which processing does is it has this draw function, which it will call every frame. So, 60 or 100 times a second or whatever it may be. And I've kept this little bit of code because it's very useful to know how much time has passed since the last frame we drew, right? Because if we want to move things or do any kind of animation or physics or kind of game logic, if the game's running at a lower frame rate, then every frame things are going to need to move further, or they'll actually like visibly slow down as they're moving across the screen and stuff. So pretty much any game system, it will either do this for you, or in the case of processing, you need to do it yourself. You kind of need to work out how long it was since the previous frame, because then you can kind of scale the speeds and animations of everything in accordance to that. So that's the basic kind of shell. I end up always writing this, so I'm just going to leave that there. Then the other bit of code, which probably has some stuff which I don't actually no, okay, I can probably use all of this. Okay, so what does this do? It basically handles some super basic sprite sheet animation. So if I look at one of these images we have, if you think about an animation, all an animation is that it's showing, one frame, it's showing one image, and then it's showing the next, and then the next, and then the next, like just like a film strip or any other kind of animation. Let me just put the grid on here. I'm guessing at the spacing here. Hey, Uncle Ox, thanks for the follow. Much appreciated. Okay, 192 pixels by 192 it seems to be. Yeah, so in order to display a sprite animation, all you really need to do is first display this little bit, and then next frame display this little bit, next frame display this little bit, and so on. And this bit of code I've copied from the previous project, it basically just does that, right? So it keeps track of a bit of information. P vector. Basically, it knows about the current animation that's playing and what's an animation. All it is kind of how long each frame should last for, how many frames are in it, like how big each frame is. Basically these kind of grid settings, right? So for example, this is an animation of this character like triggering an attack, so we need to know like what part of the image this animation sort of covers, which is this kind of bottom section here. So the way we do that is we specify the top left corner, we specify the width and height of each frame, and then the number of frames, and then from that you can always work out, the third frame is going to be this bit here, or the fifth frame is going to be this bit here. So all this little animation class does is stores that kind of stuff, right? The top left X and Y coordinate, the width and height, the number of frames, how long each frame is, in seconds in this case. We also track if it loops. Some animations you just want to play once and then they're done. Other animations, like a little idle animation, you kind of just want to loop over and over again. So this sprite keeps track of the current animation that it's playing and how long that animation's been playing for. And then given that, each time you draw it, it can work out, hey, how long have I been playing this animation for? How long is each frame? You can kind of divide those into each other, and that gives you the current frame that we're on, right? So if it's like 1 second per frame and we're 10 seconds in, then it means we're on frame 10, essentially. All this bit of logic does is it makes that loop back around to 0 if the animation's set as looping. If it's not set as looping, it just caps it at like the maximum frame. So, if you've got a 10-second animation that's been playing for 20 seconds, it just stops at the last frame. And let me just draw that frame. All this does essentially is uses a function of processing, which isn't actually that well documented. The reason I wanted to copy this is because in this stream where we did this, I spent half an hour like trying to figure out exactly how this works using scroll off the sprite sheet. So I'm just using GIMP, GNU image manipulation program, which is basically a free Photoshop alternative. The sprite wasn't made in this. The sprite was probably made in Sprite. It was made by our artist Pixel Brady. I believe they use Sprite primarily. So if I was making this, I would use a proper sprite animation tool. But I kind of almost just wanted to pull this up to kind of demonstrate to you how it's all laid out in here. Yeah, this is GIMP though. Cool. So all this does is we work out which frame to draw, and then this will kind of figure out which section inside the larger image corresponds to that frame. So we kind of clip out, essentially this draws a clipped out section of an image, so we use it to just draw the particular frame. What I was doing there, the previous version kind of had some hard-coded stuff that all sprites would always be at a certain distance from the camera and always on a certain line on the floor. I've just changed this so we can pass in just a general position and then draw it kind of at that position, kind of centered around it. The other thing is this little sprite foot offset. All that kind of does is, when we want to draw this guy, we don't want to draw him centered on where he is, and we don't want to draw him with the very bottom on where he is. We kind of want to take the line where his feet actually are, and that's where that should align with the floor. So that's all that little sprite foot offset thing does. Yeah, so hopefully we can just take it for granted that this allows us to draw a sprite. So let's actually just use this now to get something drawn on screen. How do we do this? So let's create a sprite. Just kind of be for testing. So if we want to create a sprite, what do we do? Not great naming here. I've got a class called sprite with an image called sprite inside it, which is probably more accurately is the sprite sheet. Boom. That makes me slightly less anxious about my terrible naming there. Yeah, so we can create a sprite. So and then set some of its properties. I should probably have made a nice constructor for this, but as of yet I have not. What was this called? Sprite enemy.png. Okay, we also need to add some animations into this, right? So let's pull out this kind of idle animation. So it's how many frames? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 frames. Starts right at the top left. Each frame here is 192 pixels by 192. That's this kind of square here. So we can kind of fill in that information. Ooh. All this code, by the way, will be available at the end of this, and if you go back to the VOD for the Brawler game, which this is based on all of that code, but this is kind of already up there. Okay, so we can specify this kind of stuff when we create an animation. So the top left is 0, 0. The width and height are 192, 192. Number of frames was 10. Frame duration seconds, I think it's 20 frames per second, so just do 1 over 20. Looping, true, right, because this is like an idle loop. So it definitely should loop. Then I can add this in here, so idle animation. So this class is kind of convenient, right? Because I can now say dot set. How do I actually set the animation? Change animation, and all this does is it kind of looks in that map based on the animation name you give it and stores it in this current animation variable, and then it resets seconds since animation started, since we've just changed animation, so you know the counter should kind of restart again. Change animation to idle. Then when we do this, we kind of need to make sure we update that. So sprite has a function called update animation where we pass how many seconds this frame have passed. So I find the autocomplete in the processing editor is not ideal. Seconds elapsed, and then let's try and just draw this in the middle of the screen somewhere. You can do this up top. Okay. Will this work? Let's play. I've probably got something not initialized properly or some critical bug here, but we're going to be trying a lot of sprites, so this should be handy. Okay. A couple of things are going kind of janky. Oh, you probably can't see this. There we go. Forgot to turn my little magnifier thing on. There we go. So check out this mess. So a couple of things. It's not positioned correct. It's like all the way over the right hand side, and the screen's not being cleared after every frame, so the animations are just like stacking on top of each other. You ever get that thing where the computer like freezes up and you drag a window and it like just draws some crazy stuff behind it? It's that same kind of issue basically. So let us clear the background. Black will do, I think. Okay, that has fixed that issue. Did I position it? That's strange. I think we're doing something weird with how we are actually positioning this probably. Oh, I've got a hard-coded width over 2. See, yeah, my my thing was definitely a bit janky before. Okay. There is our dude, looking good. So yeah, this is the kind of basic thing we're going to use for our zombies and also for our little plants. I mean, they're not actually going to be plants, they're going to be these same characters. Okay, where do we go next? Let's think about how we're going to sort of architect and like design this whole thing. I can find my little tablet pen. Every time I try and draw with this tablet, but it never totally works. I keep trying. Okay, so how's this game going to work? So, ninja zombies with knives, yeah. That's more terrifying than the real game, which has like zombies with trash cans on their heads and stuff like that. So, we're going to have these lanes, right? Some number of these, like, I don't know, 3 or 4 or whatever makes sense to us. So there's some kind of a grid which is going to determine where you can place your characters. Because in Plants vs Zombies, you can't place them wherever you want, right? It's like a... So your things are on a grid, but the zombies are not. They will move like continuously and steadily along until they get close to your things, and then they'll start like juking it out. So we need a grid in terms of where our things are placed, but the zombies need to be able to be at kind of arbitrary positions, I think. And I think it would be nice if we could think of this as like 0 position. Since we're programmers, good programmers, we love to think in terms of 0. So maybe if this was 0, this was 1, 2, 3, 4, 5, 6, 7, and then I guess 0, 1, 2, 3, something like this. So we kind of have coordinates for all of these cells. I think that seems good to me. So our little guy is going to be... I cannot draw. Ah! Oh, where's the body? Let's make that the body. Okay. Our guys are going to be placed on these cells, and then the zombies are going to be coming in from the right-hand side. So, you know, maybe their position starts at like 8, and then that's just going to gradually decrease, and they're going to gradually step along, and along, and along, and along. Kind of like that. Yeah, that's supposed to be a zombie. Yeah, okay, so I think I'm going to go with this kind of approach. So we probably need, what do we need? We probably need like a list of our units, like maybe we call them heroes. A list of hero, which kind of has all of our units. We're going to need also like an amount of money we have in the bank, because these hero units are going to cost a certain amount of money to place them. So, you know, like into money or something like that. And then for the zombies, I think it makes sense probably to have... Okay, here's a question. Do we have a list of heroes, or do we have like an array of these cells which can then contain heroes, right? Because we could have something like hero, like a 2D array of heroes, which could be null, and then that would map to this grid. Okay, I kind of like this better. Ooh. This is why my tablet does not work very well. Okay. Yeah, I kind of feel like I prefer this because it means we could never have a hero in a dodgy position. So we have ditch this. So we're going to have a certain amount of money. We're going to have a kind of 2D array of heroes which maps directly onto this grid. Now, the heroes themselves will have like their health and different behaviors. Some of them may shoot, some of them may just do like melee, some of them might just be blockers. Those are the main types in Plants vs Zombies. If we can get one of each of those, that's probably good. Or the other type is heroes which like generate more money, which in Plants vs Zombies are these little sunflowers. So you'd normally place these first. They would generate sunlight, which is kind of your currency, and then you would spend that to place your like combat units and stuff. So we probably need that, and then we also need our zombies, and I think the way to do that is to have a list for each lane, because zombies can only ever like move in their own lane, right? So I think I want to have something like an array of lists of zombies. So let's say enemy. Wow, I should not try and draw code with a stylus. Okay, and then like an array, something like that. So this index would tell us which lane they're in, and then this list would just have, you know, you might have multiple zombies here at different positions. Kind of like that. And then when the game kind of runs, we can go through all of our heroes, we can update them, which means they'll fire off their projectiles and whatnot. They'll generate money for us, whatever it is they do, and then the enemies can kind of shuffle along these little things. Okay, so probably it makes sense to do this with just one lane first, right? Like start super simple. Or even to create a class to kind of represent our hero units. Oop. You wear caps lock. Let's give it a sprite. What else might I need? Like health. That's probably all. So, and then in terms of methods, we probably want to give it an update. We can tell it, hey, this amount of time has passed. What did we call that parameter before? Seconds elapsed. Oh, it wouldn't rename it because I didn't. Let me see if I can do this. I'm not a huge fan of this editor, to be honest. I really like processing, but the editor's kind of janky. Okay, so we're going to need a method which is called when it's updated, and at the very least we want to like update the sprite when that happens. And then it's going to need a draw method as well. We can just kind of draw the sprite at that point, right? And then I think what we'll do is we will probably have subclasses of this hero for each different type of unit. That's maybe not the ultimate cleanest architecture if you did this in a real game, but I think since we're only going to have probably 3 types of hero, that's probably right. So let's make this an abstract class hero. If you're not familiar with abstract class, what this means is you can't create just a hero, right? We're going to make like a shooter and like a meleeer and like a money generator hero, but there's no such thing as like a generic hero. You can't actually make one and put it on the battlefield. It needs to be like a subclass. So that's what abstract does. It means I can't just create a generic hero. So let's create a simplest one is probably our money generator hero. If anyone has a better name, I am more than open to suggestions there. So our money hero is going to extend our hero class. Let's give it a constructor. Probably want to tell it where it's going to go, like physically. I want to create a sprite for it. So let's see what we've got in the old bank here. So this is one of our sprites. I think I'm going to use this for the basic zombie. This is another sprite from Steamhounds, which is the warrior. They're kind of a melee person, so I think we can use those for our like melee attacker. Loads of cool animations here, like they even have like a crazy death animation, which is pretty cool. Okay, I'm gonna dig into some unreleased sprites for Steamhounds to find one that makes sense for our like money generator. So excuse me while I do stuff off on the other screen and go through some super secret unreleased stuff, but we shall pick something out here. Trying to think which kind of character would work here. I need one with an animation that makes sense for like generating money. I mean, it's kind of strange. So is an actual sprite editor program. So I'm going to pull out this ranger, which I'm going to use for has their little idle animation, but also they have like a ranged attack we can use. So they have this little loop where they stand there with a gun. They have one where they actually shoot. So I think this is going to be our ranged attacker. Need to pick another character we can use for generating money. So we have this engineer character. Scroll through these animations to see if anything makes sense. Okay. But I don't have a character literally like harvesting coins or something, so this is probably about the closest we're going to get. Maybe we can use this little, what was it? This little thing as like, you get money when that happens? I don't know. So what I'm going to do is just chop out the bits of the animation which I actually need. Throw those on a new layer. So we need the idle loop. We need the collecting money little animation there. Okay, that's all this character will do. Okay, just going to try and then export these onto a sprite sheet. Oh, that's super wide. What's going on here? Ah, lost my save window. Where are we? Hey Sprite, what are you doing? Oh, you know what? There are a load of extra frames which scuff that up. It's also got a dying animation, to be fair. I feel like that would be appropriate to use as well. Where's his glorious death animation? Oh, you know what? This isn't even the final version of this sprite. You can see there's like some placeholder junk in here. Looks good enough. We will use that. Okay. Delete all of those. Export this to a sprite sheet. Yeah, this is really weird. So I'm trying to drag this off to my second monitor to not show you every file on my computer, but it like doesn't appear on the other screen. It's like if it's not within this window, it's... See what I mean? It's getting cut off. It's not a proper window. So... split here. Okay, here we go. Now I should be able to edit this. So what we're going to need to do is make sure that the grid is set up, it's the same scale as everything else and so on. Because right now it's just a massive, super long image. Check he's kind of at least vaguely the same scale as the other sprite. Oh, he's way small. Okay. Yeah, you know what? I think what I did was that I just scaled this thing up. I was super lazy and I just scaled it up in image form. Yeah, it's like 3 times normal size. But this guy's animations are really long. If I scale this up to 3 times normal size and then try and load in like a... See, there's like a 10,000 pixel image. That's not gonna work super well. So I probably need to scale this back to actual size. Ooh. Not like that. Okay, you can always screw stuff up when you're scaling pixel art, but this seems to be okay. So let me re-export that. And what I'll need to do now is tweak our little thing to say it's no longer 192, right? It's a third of that, whatever that is. Arithmetic cannot do it. 64. Probably means it's going to be tiny. Wee little guy. Okay, so now the pixel art's like 1:1, so it's not going to be a crazy massive image. And I can always scale this up. I can scale everything in the game up just with like 1 line of code somewhere else, so it's not a big issue. Now I can take this dude. I want to, because my code for displaying these sprites is not super advanced, I'm gonna just put 1 animation on each line. Like in reality, you'd want to pack these animations in tight, right? Like this is not very optimal, but it's just the code is slightly convenient and more simple if an animation doesn't ever like wrap round from one line to another, because you just have to account for that in code. So I'm just going to be lazy and not do that. I'm going to put the grid on so I can chop these up properly. Up to grid, please. Okay. What's the longest animation here? Probably going to be... Hey Critics, how's it going? We are just working on a Plants vs Zombies clone, and we're just figuring out which of our little Steamhound sprites to use for that right now. So I am chopping some sprites right now. So this one is... 1,500. I need to figure out which is the longest animation, because that would determine the length of the image, basically. Okay, it's this one here. So we've got 3 of these, so the image needs to be 3 times as tall. Then I can start chopping out these individual animations. Kind of move this down here. The same thing with the final animation. Copy this whole deal down here. make sure we are lined up properly. Cool. I think good there. Okay, so I was thinking, I know that this guy is actually centered in his grid, whereas this guy kind of has an offset. I was going to correct that, right? I was going to shift all of these over so that he's like standing. I don't know if you can see this grid line super clearly. So he's standing like centered in it. But actually, it's kind of going to be more convenient if I have him offset so that when the game thinks him and a zombie are in the same position, the zombie's actually like right in front, because then it will mean that their attacks and swings and stuff line up a bit more easily. Kind of cheaty, but I think that will be more convenient in the long run. Okay, I'm just going to crop this down to the requisite size. Still pretty big image, but at least processing will hopefully load this. So I've got an idle animation, I've got a when his ability triggers and he gets us some money basically, and I've got the death animation. Okay, leave that back down. So now our money generator hero is a new sprite. We can now set up the sprite like with the image we just created. What I'm going to do is actually load all the images up here. I could load the image here, but then every time one of these is spawned, it's going to load the image from disk again. So I'm going to be a terrible programmer and just put some static, like global things to contain those. In reality, I'd probably have some like cache service or something to do this, but this works for now. It's in the spirit of processing. I keep telling myself to just kind of hack stuff together like this. So the sprite sheet for this is going to be the ng image. What else do we need to do to set up the thing? So it needs a position, which we'll figure out later how to do that. That's done already. An idle animation, it's not 64 by 64. Yes, I am just coding in these parameters into each class. Don't at me. So idle animation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 frames long. 12 frames long. It's each frame is a 20th of a second. It does loop. We're going to load that in and we're going to set it to be active. Okay. Okay, so here's a question, right? We've got our kind of playfield, and we need to know for a given coordinate where, like in the world coordinate space, do we actually draw that thing? So, I originally said I would do this 3D. Maybe I will just, for now, just get this drawn on the screen somehow. So, let's think about this, right? So if our whole screen in which this grid lives is kind of like this sort of area, then what we need is like a position for this cell and like a width and height of each cell, right? And then we can sort of derive from the coordinates like where something should be positioned. So I'm going to create a little utility class just to wrap some of this stuff up. I can just throw some stuff in here. If you're used to Java, by the way, there's some weird stuff with how processing classes work. Because under the hood, you notice this stuff here isn't living in a class, but under the hood it actually is kind of wrapping it into a class, which creates some weird things to do with, like, these are actually all nested classes of the main one. Kind of a tangent, but it means that there are some weird things which you would expect to be able to do, but you can't actually do in processing, so... Make a little convenience function. Which takes a grid coordinate, like 0, 0, or like 2, 1, and then returns the actual position on screen that that corresponds to. All the other code can pretty much then use this. So going to be x plus row times cell width. So if row is 0, then it's just going to be what we've defined as the top left. And then as row increases, we're going to step along by the width of a cell. Autocomplete. Okay. And the reason I'm doing that ultimately is so I can say right, so it's now, rather than just this sprite, I can say more like this, so something like this, and now hopefully we should see our engineer idling around at a certain position. Nope. It's not like that. Oh, you know, I did not load probably need the file extension. That's not a real file format. Okay. Has my camera been slowly rotating? I've got a whole blue tack and stack of crap arrangement as my tripod, so... Okay, we are seeing... Yeah, it's rotating, that's really off-putting. Okay. But there is our dude. He is there. He is... Whoa! Okay, that's because I'm scrolling around the screen. Okay. Seems to be positioned reasonably. We can now change this setup to be... We talked about having a 2D array of heroes, right? Then let's give ourselves a little spawn hero function. Like I probably want an enum available heroes. Then I can say a little kind of hero generator function here. So then based on the type I can instantiate a different kind of thing. So if it's not matched, then there's nothing we can do. Excellent programming practice there, I'm sure you will agree. Okay, so we've got a little convenience thing that can spawn a hero of a certain type into a certain slot, and that will just instantiate the correct thing and then shove it into the array for us. So let's instead here do spawn hero. You can imagine later on this will be done by the user actually clicking stuff in the UI. Autocomplete. It does this annoying thing which proper IDs don't, where if something else is like not totally valid, it will autocomplete will kind of fail universally. Also, yeah, it just doesn't work in all situations that it should. So let's spawn one in 0, 0. Let's spawn another one in 1, 1 just to check this looks reasonable. We should probably many rows, like 8. No, 4. I just want to call this world actually. Okay, so make sure there's space for all of these. This will load some of them in, and then when we do this, we kind of just want to loop through. For the rows and columns. And look it up, and then say if it's null, we can just skip this one. Otherwise, we're going to update it, and we're going to draw it. Okay. I haven't done a great deal here, but what I've done is kind of structured things such that I can have a dynamic set of heroes. I can place them in certain positions with little one-liners like this. And then hopefully they will get drawn in the appropriate slots. We've got one in 0, 0, one in 1, 1. That looks okay. Probably the distance between them is way too big there, so we can simply tweak this. actually know that these biggest sprites are like 128 by 128, so it should mean they don't overlap. Nice, okay. You know, maybe we want to move it up a bit, so you can play around with that kind of thing. I have the basics of this field, and I can plug my heroes into that. Nice. Okay. So what else constitutes our kind of game state, right? So we have separate assets from like game state. Yeah, so we have our heroes, we have an amount of money, right? It started at, I don't know, 100 kind of arbitrarily, and we should probably draw that into the screen somewhere. So let's just say I think that's the syntax there. Cool, that's super tiny. The text size. Nice, okay. We have our super sophisticated UI here. We've got our sprites loaded. We can draw them in at certain positions. I'm going to take a quick break shortly, but first I think I will just give this guy some behavior, right? So what should this guy do aside from sit there in his little idle animation? I think he should probably wait a certain number of seconds and then generate us some money, right? So let's just say let's say every, I don't know, every 10 seconds. They're going to give us 25 monies, like that. So now what I can do is kind of override the update function, right? So if you remember, the class this is based on and inherits from has an update function as well. Yeah, see something weird going on there. The class sprite does not exist, but here it is. It gets in a weird state with stuff being saved and cached and stuff. So we still want this to happen, but we want to inject some of our own kind of logic as well. So we can just override this function. And remember to say, hey, call the update function on our parent class as well, which will handle just updating the sprite animation. And then you want to have a counter probably, right? So we know what this interval is. We need to count up to that. So I'm going to say if the money interval counter is greater than the money interval, so if enough time has passed that we should give the player some money, I'm going to say be super verbose because that's just who I am and I've accepted that. We create that money, then we just reset our counter. kind of want to be pernickety and subtract this. I could just reset this to 0, but I feel like this is slightly more correct in a sense, because what if we've slightly gone over the counter, right? We don't want to reset to 0, we want to carry over the difference. So that's, you know, if it's a 10-second counter and it's been 11 seconds, we should give money and then reset back to 1, so that we don't, like, get slightly behind every time. Not a big deal, honestly, but it's a bit fairer, I guess. Otherwise the gameplay would be slightly different depending on frame rate and stuff, which is kind of not ideal. Not a problem for a single player game, really, but I'll stop going about this. I just feel like it's the right way to do things. I also want to change our animation, right? First we should actually store the animations in. That's the idle animation. Let's add the money animation. So we know that the top left is going to start at 128. Size of the frames are the same. How many frames does it have? A whole bunch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 31. Oh, sprite animations are kind of crazy. Okay. Okay. Just gonna play the money animation. So this will work, but we'll notice a little bug which we kind of need to fix. So if we wait 10 seconds, we should see them fire off and we should see our money go up. Yeah. But you'll notice the animations did not reset. That's kind of what we need to detect. And right now, I don't think we have a super convenient way to do that. Okay, yeah, the animation just triggered again. What I kind of want is like is animation complete, right? So where we can do it's complete if the number of seconds since it started, god damn the autocomplete, is greater than or equal to current animation dot number of frames multiplied by, right, hopefully this makes sense. So if there are 10 frames and they're each half a second long, then that's going to be 5 seconds total. So if the animation is playing for 5 or more seconds, then the current animation is complete. But that may mean it's just looped back around again. It means it's played at least once, basically. So now we can say something like this is also not the best place to put this, but now I can say something like if clean this code, just repeating this constant over and over, but what are you going to do? What do we call that? So if it's playing the money animation and that animation has finished, then we want to reset the animation to idle. Yeah, so as I say, normally this is not the cleanest way to do this, like to have this bit of logic reach into the sprite and check the name of the animation that's playing. It's not the ideal place for this logic, but really this class is not going to get any more complicated than this. You know, if you can look at a bit of code and see all of it on screen at once and understand everything it's doing, then even if it's not the cleanest architecture, I feel like that's generally okay. In a pragmatic sense at least, and especially for these kind of hacked together prototype dealies. So hopefully we now see our little guy fire off and then reset to the idle animation. Oop. Nice. Pretty seamless. They're generating money for us. We have our sunflower unit equivalent. Awesome. I think we can be pretty pleased with this. So for now, I'm going to take a short break and I'll be back in a little bit. So catch you in a few minutes. Okay, welcome back. You can see this has still been running and our little engineers have racked up some big bucks for us in the meantime. Fortunately, I'm going to kill this off now. So what's next? I think... Okay, yeah, let's add an enemy in here. And start thinking about how they work. They're probably going to be kind of similar to the heroes in a lot of ways, so I'm going to start by just copy pasting that class. Maybe I should have had a common base class, who knows. In fact, looking at this now, I almost certainly should, but I think the main difference is going to be how the positioning works. Right, because heroes, I mean, when we initially create them, we need to put their sprite in a certain position. In fact, we can do that in the base class, I think. Probably makes more sense. I've mixed col and column in my code a bit, but I think we're good. Okay, and then when I do this, I can just call these super, which will set up some initial stuff, and then it's really only the visual aspects of the sprite sheet which I need to handle. I almost said manage or handle myself. Which means again I can copy. Maybe not. Okay, so I think rather than row and column being integers, I kind of want an X position and a Y position, which will be in the same coordinate space, but I figure the enemies can be at like fractional coordinates. So if our heroes are at like 0, 0 or 1, 0, an enemy can be at like 7.2 and be sort of, you know, here somewhere. As they're going to like continuously move along rather than like do like a lockstep thing along the grid. So I'm going to keep these as floats, and then I think what I'll do is when I update it, I'm going to set the position to be the X and Y position like that. Okay. And then probably the constructor will also need public enemy. I'm really tempted to write number 1 now, but okay. Don't mind me, I've just got my little snack here. I'll do you the favour of turning my mic off while I consume that though. Okay. So we pass the X and Y, we just save them off, and then every frame we're just going to update the position of the sprite to be the world position of our sort of grid position here. Okay. So let's give ourselves a... Do we split the enemies into lanes, or do we just keeping them each a position. I think splitting them by lanes is probably going to be the easiest thing to do. And I feel like it may help us in the future, so let's give ourselves a list of enemies. Nope, that's not how you do that. A list of enemy and an array of those. Thinking of a linked list because the way I'm going to be removing them when they get killed and stuff, that kind of fits with that. Okay, those are heroes. Enemies is a new cannot create a generic array. Can you not do that? Is that not a thing? Okay. So what have I created here? I've created an array list of linked lists. It's weird, I thought that I could just do an array of linked lists, but maybe they don't play nice with generics in Java. Yeah, so this is the way I'm going to do that. Although I kind of just want to use this like a fixed size array. So I've created a number of lists, one for each row, and put an empty linked list in each of those. So now I'm going to create a spawn enemy function. Spawn enemy. And this is going to be very similar, so we probably want an enemy type enum. Let me try and sort this camera out. What's enemy types? Create a regular zombie. Or a walker if you're thinking about the behavior. And let's create a walker enemy class. Okay. Use public. Extends enemy, and then it's going to be something similar to our money generator substance. It's going to have slightly different logic probably. Let's do it. Let's give it like a speed per second of how many seconds should it take to walk along a grid tile? At least several, right? So like that. Okay, enemy. Image, no, it's going to be zombie image. this in. What was the actual file name? Just sprite enemy. Let's call it sprite walker. Zombie, I don't know. Okay, let's load it in. The walker is going to use it. The idle animation for this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 frames. Actually only 64 by 64. 10 frames, it does loop. It also has a hurt animation, which I remember is just 1 frame. Let's make it last a bit longer. And it has attack. How many frames was that one? 11. Either it's going to start off idle. Okay, I think what I will just do here is the logic's just going to be something like this. Right, so its X position is going to slowly move to the left. Although probably if it's less than 0, we should just set it back to 0. Okay, so this should kind of do its thing. I can implement this. Again, I'm going to kind of copy this basic structure. Change my mind, I'm no longer going to paste that in. Okay. Okay, so should probably still give it an int for the row. Just give it an x plus like that, right? So row is kind of y and column is kind of x. The x position is going to be the x position. It will cast that for me, but I kind of like to do that, make it super explicit. Okay, and then so we're going to take the list for the particular row. And we're just going to add the enemy to it. Okay. So probably I feel like we should update everything and then draw everything, rather than update and draw the heroes and then update and draw the enemies. Like, you know, if one of the enemies kills the hero, but we've already drawn it, then it's going to kind of be out of sync. So what I'm actually going to do is kind of split this logic up. A bit of duplication of this loop, but again, I feel like it's a bit more correct if we do it this way. So let's update the heroes, then let's update the enemies. This is a particular row. Ultimately, I'm probably going to have to use some fancy iterator because I'm going to want to be removing these things as I'm iterating through, potentially if they die. So e.update. Seconds elapsed. Okay, there's the update, and then I'm just going to draw them in a similar way. Call e.draw. Okay. And let's check it compiles, even though I haven't added anything yet. Okay, they're still there. Let's try throwing an enemy into the mix. Up here, I'm going to spawn an enemy. You know, and when I'm making a game, this is generally how I will, especially these simple things, it's generally how I'll work things out, is focus on implementing the function that will do this before I worry too much about creating the UI and actual interaction, which will do this dynamically. Because once you've done this, it's half the battle, right? You can kind of just code these things into existence, create enemies all over the place, and the logic of spawning or buying heroes and stuff is generally easier after that. So go to Walker. What was the... which row would it be in? It's going to be in row 1 on with that little dude, and then way over to the right somewhere. You probably want like a thinking like a bit more to the right of that. Okay. On in now. Are they going to behave as we would hope? Nope, we're going to get a null pointer exception. So probably the sprite is null, which would be because the enemy didn't set it, which indeed it did not. The hero did this. The enemy didn't do jack. Okay. Boom. Okay. You probably can't see this, but there is indeed an enemy moonwalk shuffling his way over. So clearly that needs to be flipped back to front. Sorry, been a long day. Super hungry. Okay. Let's flip this dude. Oh, also it looks like their feet aren't aligned, so we need to make sure that we account for the foot alignment, which there is a feature for in the sprite, but we're not actually setting this yet. Facing left, something we want to set here. Because all our enemies will in fact be facing left. Okay, that's working just fine. Now we just need to make sure the offsets are correct. I'm going to peek into this code to see what we actually do with that offset. Okay, so I believe it's an offset from the middle of the frame to the foot of the character. So kind of go from here, and that offset that you can see at the bottom of my screen down here, it's showing me the size of this little box I've measured. Like 62. Autocomplete. Getting a bit janky mixing like visual stuff with like the logic in here. Not ideal, but I will allow myself this. So now for this, oh, nope, this one. The difference between the midpoint and the feet is about 19 pixels. 19. So I may have had the sign wrong. This may need to be like minus 19, but I will see if they look visually aligned here. And they do. There's our little creepy crawler. If I print screen this, we can see that in fact their little footsies do indeed line up, so that appears to be working properly. Cool. So I think the next thing is to have some kind of interaction between these two things, right? So probably what should happen is when this guy gets to maybe the center point of this tile, they should start duking it out, right? Because they are kind of in range of each other. So I need some logic, probably common to the enemies, which is going to be like something like this, right? So just thinking in my head how this is going to work. So we know that this guy's positioned like right on this grid line. So I think when the enemy gets to that point, or actually if you remember this sprite had, this one is centered whereas this one has a kind of offset. So probably actually the grid line is like here, which is kind of convenient because we can then just say, a bit hacky, but when the enemy and the engineer have the same coordinate, they will like, the enemy will like visually appear to be here. It's probably a reasonable distance for them to start duking it out. So what I want to do is have them stop here, or detect that there's somebody in front of them and then stop. So we kind of need some little equation here to figure that out for us. So so what I'm considering is there's an edge case where frame by frame the enemy moves, and it may be that he moves slightly beyond this, but then we kind of want to then like bump him back to this exact position. That's where he should stand. So we need to account for that little transition, right? So I want to do something like, somehow here I want to kind of check, not just get, but like check for and kind of account for this somehow. So the row we're looking is there. Hero. So if we go back to this example, if the enemy's here, then their position is going to be, this is 1, it's going to be 1 point something, whereas if they're slightly on the other side, it's going to be 0.9 something. So I think we should probably round to the nearest number and then check if we're like on this side of the thing, essentially. If we haven't quite reached that mark, then we're not there yet, but okay. So actually the Y position. So if okay, so if our actual X position is greater than, okay, so this is the rounded position, right, which is 1. Our actual position is going to be 1 point something here and 0 point something here. So if our X position is, if our rounded X position is 1, then if our actual X position is greater than that, then we haven't yet reached it. If it's less than that, then we have, and we should end up fighting that. Or maybe we should even have, I'm wondering what should happen if, this is really kind of in its case, if the player, if the enemy moves to like here, and then the player places this down, should like bump the enemy back. I think we should probably have some threshold, right, where if the enemy is exactly on the line or some distance in front of it, then they're considered to be like on the line and in that slot. So let's say if xboss is greater than just say 0.1. So now they're in the right, so okay, let's hero. If hero here is not null, then I'm gonna in fact, I feel like I want to call this rounded xboss. If you can hear my housemate's dog out there. Okay, this is a bit of a mess, but see the semicolon, where would that be? I feel like I'm not. Yeah, there's something where it just does not, gets kind of out of sync with the saving. In any case, okay, this is kind of janky, but do that. You know what? Let's actually put that. Maybe in here. Yeah. Okay, that should do. Not doing anything with that now, but it should cause this guy to stop when he approaches our engineer. I'm going to put him a bit closer just to test this. Probably got some sign or check the wrong way around. Getting closer, getting closer, getting closer. Close. Okay, he stopped. So they've clearly detected thing there. So one thing I should probably do is determine how many kind of hits they can take, maybe. Class. Oh, okay. Okay, so I think what I want this enemy to do is if the hero is not null, then I want to play the attack animation. What I'm doing, which is kind of dirty, is I'm using the current player animation as a kind of state machine, when really I should just model that here somewhere more nicely, but I have no excuse, so I could not finish that sentence. Okay, so what's going to happen here? We're next to somebody, so if we're not already attacking, then we're going to start attacking. Otherwise, if the current animation is complete, then we can actually damage that hero, right? And then we can start another attack loop. Well, if the hero is alive, we can start another attack loop. Otherwise, we can so there's nothing in front of us, we kind of want to switch back to idle if we were attacking, right? Okay. We can do that. And then we can do something here like if there is no health, then you just blank the hero out for now. In the future, I'm going to play their death animation. For now, we're just going to have them disappear. So what should we see? Our hero should have 10 health. The enemy should roll up. It should do attacks, and then the health should be reduced. That should happen 10 times, and then our hero should disappear. That's pretty much Plants vs Zombies, right? That's kind of how it goes. So we probably need to detect if they've gotten all the way to the end and kind of end the game. So I could probably do something really janky like these enemies. So if e dot. Oh, we need this logic as well, right? We need to be able to delete these enemies. So how do we do that? Rather than just iterating through with this handy for loop, we need to use something like an iterator. What an iterator is, in Java, it allows you to go through a collection and iterate and remove things kind of as you're going. So it handles, if you've ever implemented the linked list, it handles all the updating pointers and stuff to take something out of the middle of the list. We can use a for loop for this as well. It's going to be get the iterator, and then while the iterator right. So we just call this next, which will kind of step through the list for us, handle all the state of keeping track of where we are in the list. We can update it, and then I can just say if e dot health is less than 0, then remove the current item which we're on. So it's kind of a handy way to iterate through something like that. In fact, I don't like abusing, well, it's not really abusing a for loop, but I don't like using a for loop in a way that's not a very standard way, to be honest. I feel like this is a bit cleaner like this. So when you get for loops with like multiple colons, because you're not using one of the 3 little sections you can fill in, it's kind of janky to me. So we grab the iterator from the enemy list, and we keep looking through while there's more enemies to process. Check the next enemy, we update it. If it's dead, we remove it. Enemies can't die right now, but let's say else if they've got like past the end. Then let's just do exit like that. Which means the enemies probably should not reset themselves if they go less than 0. We can ditch that. Now we should be able to see the game over should appear down here ultimately. Oh, where is our dude? Oh, he's got no health, really. Yeah, this guy went down pretty quick, so I'll up that just so we can test the logic. Let's run it like this. Okay, he's going to run up on our engineer. Going. Eventually when he gets to minus 0.5, there we go, game over. Zombies 8, yeah. Cool, so the logic for these seems to be more or less good. Let's do something like I kind of want to play the death animation. So let's separate the idea of the health being 0 from them actually being like dead and properly ready to remove. I think what we can do is we can say basically ignore heroes whose health is 0, but then I can say something like where are we? Yeah, right, so like if health less than or equal to 0 and we're not playing the okay, it's like this, so if we're not playing the death animation, then we want to play that. Otherwise, if we presumably were playing that and the animation is complete, then we can flag ourselves as properly dead. Then we can be cleaned up. Quite often in games you have to separate from the concept of something being dead in terms of gameplay, like logically not going to affect anything anymore, and cleaned up in terms of all the death effects of finished playing, and you can actually clean up all the resources associated with it. So yeah. It's the dead, we're going to remove it. It's the dying logic. I can probably push this. Maybe not. Okay. Let's add the animation in here, so I need to know how many frames and so on. Frames 1, 2, 3, 4, 5, 6, 7, 8, 28 frames. Starts at 256. Not loop. It is called die. Die. Here we go. If that happens, we don't want to do any more logic there. Shuffles along, smacks them up a few times. Oh, leaves him for dead. Awesome. Okay. So I think to make this, I mean, I'd really like to finish like making this some kind of actual playable game in some sense of the word. Sorry, this is super annoying. Yeah, I might have to buy a tripod. Okay. I think I need a couple more, or at least one more hero type who can actually damage the enemies. So the easiest way to do this probably is load in another sprite sheet. So I'm just going to use the ranger for this. We need idle. No, I was going to use, okay, this support loop. The idle. The fire for them actually shooting. And then probably them dying. Wow, a crazy long animation. Okay, delete all these other frames. We'll export this out. We've already got the warrior logo, okay. Export. Put her up. Can't see anything because I've got the layer hidden. Cool. Okay, let me just scale this up again. Whoa! It's huge. This 1:1. It is, it's just that huge, okay. So, times that by 3. I only just figured out recently I can put equations on here and it'll get them out, which is very, very convenient. I do a lot of stuff like this with sprite sheets. To grid, please. You know, that's part of this animation I don't actually want, so there's like a glowy effect as well, which I think is unnecessary. There's the loop and then fire. Oh, okay, I'll keep it. Whatever. It's kind of charming. I'll just move this down. So I've kind of stuck to a convention of having the idle on the top, and then the sort of activate action on the middle, and then the third one can be the glorious hero's death animation. Okay, I can just crop this down to just cover all of these. So many frames. It's kind of insane the work Brady's done on these characters. Okay. When images get this big, I kind of start to worry that processing will have some trouble loading them in. I think I'm done with this. Let's kind of just copy and paste this to a ranged hero. Let's just think about how the logic will vary. Shall we say shoot interval seconds? Maybe it's 10, maybe that's too much, I don't know. Let's give it a little more health. Let's give this one more health as well. Okay. The only difference here should be the number of frames really. So how many frames are in our shoot animation? 1, 2, 3, 4, 5, 6. 20. And in our getting killed animation, same number. Actually, just going to use a calculator for this. So 11624 divided by 128 is 10624. 10624 divided by 128. 83. That is insane. Okay. Can that be right? Okay. Third time. We're insane with our animations. Okay. So we can keep this logic. I wouldn't like it to be copy and pasted, but that's what's happening. If the timer has kind of gone over, nope, don't do that. So what I think I want to do is, when the animation ends, I'm going to basically look for an enemy immediately in front of me and just deal damage to them. So it could be something like enemies. So that should be in my row, right? So loop over every enemy in my row. Let's save that as row. Should probably save these off. Interesting, I never actually kept track of those. So this dot row. Row. Save off the column as well. So get all the enemies for this row, iterate through them. Let's say so if the health is greater than 0 and X-boss is greater than or equal to my position, right? Because I can't shoot something that's behind me. Then if, okay, since to enemy is going to be, oh. Actually, let's just do it this way. Enemy is greater than or equal to 0. Then this would be the closest one we've seen so far if so what are we doing here? Hey Paul, yeah, it's going pretty well. So we've got this Plants vs Zombies clone going. Our code's probably in a broken state right now, but I'm about to run it and you should see kind of what we have going on so far. What I'm doing here is just figuring out you have like these lanes, right? Plants vs Zombie style, and I kind of need to figure out who's the closest enemy in front of me. So that's kind of what I'm doing here. Okay, so we scan through all the enemies looking for the closest. And if we found one, then we kind of want to damage it. Okay, so things not on the battlefield yet. We should kind of see what's happening. Okay. So mostly for Paul's benefit, I'm going to show you where we are already. So we have these two units which kind of periodically will generate money, and you'll see them firing off a certain animation when that happens. I think somebody there. We have this zombie kind of crawling in, and then when they get close enough, they'll start swinging. When they eventually damage our guy enough, we'll get killed, and then our enemy will proceed forwards. And ultimately, if any enemy gets like past this line here, then they kind of win. We get the game over. There we go. So, not very pretty. There is no UI, but that's what we're doing right now. So I've just implemented now another hero type, which is our kind of ranged hero. Yeah, right, but like we've got the rudiments of the gameplay down. Yeah, I figure I'm not going to let this run too long, so I don't know if I'll get to the point of actually like placing these down. Maybe this is something we can do a part 2. We can add some more UI and we can add the actual like wave spawning logic. You know, I could probably rush and get something done in maybe half an hour, but maybe better if I actually explain what's all happening. So, move him to the right and add another hero here. Column 2. Yeah, right. Like they're so cool. Like the death animation for the ranger has like 80 plus frames in it. It's kind of insane. Oh, you know what? I need to make sure I actually load the sprite. Put them in the right place. Right, ranger. The ranged hero should use the ranger sprite. Okay. I haven't tested any of this logic, so we'll see what happens here. I'm hoping that she will shoot, and then this is going to damage the sky. There's no visual indication of that right now. Let's try maybe upping her fire rate a bit. Health bars would be good as well, right? Yeah, you know what? There's so many extensions we could do to this. I may just have to pick it up next week. Okay, so our range is firing away. I trust that our enemy's health is actually being reduced. Who will come out on top, Ranger or zombified Gangoon? Oh! Went straight past her. That's weird. Okay, there's a bug. What causes that, I wonder? There's probably something here.